Hi everyone, welcome back. So in this video, I'm going to discuss about a very well-known topic to everyone, which we call as malicious software, often commonly referred to as malware. So this is one of the most sophisticated types of threats to computer systems because of the programs which can exploit any vulnerabilities that are found in our system. To have a little bit of background, if you remember, these vulnerabilities are nothing but weaknesses or some kind of defects which are caused either by hardware or software, which the malicious users like attackers try to exploit. So if they can exploit these weaknesses and try to penetrate, and or if they are successful enough to penetrate our system, they could really take control of everything. So using an exploit against a vulnerability is referred to as an attack. So this is what we call as malicious software. And as I told you, in short, we call them as malware. So short for malicious software, malware is any code that can be used to steal data, bypass access controls, or cause harm to or compromise a system. Now, traditionally speaking, software is regarded as malware based on the intent of its own creator. So the person who actually wrote this code, what is his intent? Is he having a harmful intent, or he's trying to do something good? Based on that, we categorize that software as malware. I can't simply say that look at a software and say it's a malware kind of thing, because it is not based on any particular features or characteristics. So this is what any software which has an harmful intent to either steal the data or bypass access controls or even modify the data, even cause harm or destroy some of the resources. Like such kind of things are called as malware. There are many types of malware present, and these are the most common types of malware. The first one being the virus, which we know very well, and the second one is worm. The third one is logic bomb. The fourth one is Trojan Horse. Fifth one being the backdoor or trapdoor, keyloggers, rootkit, zombie. So the list does not end here. There are many additions to the list. So every day, new types of malware keep popping up in our world, and the list keeps on growing. In this video, I'm just going to cover maybe 4 or 5 uh, in-depth discussions about each one of these malware types. For the remaining ones, I refer you to my video on Introduction to Cybersecurity module 2. I'll give you a link in the description if you want to. So there you can have much more different types of malware. Okay. So let us first discuss about how do we categorize the malware. Malware can be classified into several categories depending on two things. The first one being propagation and the second one being the concealment part. If you ask me, what do you mean by propagation? Propagation means whether the malware can propagate automatically or it needs any human assistance. Examples of malware which can propagate automatically without anyone intervening are worms and even zombies to some extent. Whereas malware which require some kind of human intervention for them to propagate are viruses and logic bombs. That is what we call as propagation part. Coming to the concealment part, if any malware is trying to hide itself from antiviruses, and if it does not appear to be an malware, then it is called as a concealment part. So if the virus tries to hide itself, or doesn't matter if it showcases itself and its harmful intent and tries to take over the system. So that is how you actually categorize the malware based on its propagation thing and also the concealment part. So in case if it appears to be a good one, but it tries to do a harmful action in the background, one of the best examples is a Trojan horse, which we shall discuss in the later part. Whereas rootkit, it appears, it actually does, it is very hard to detect where a rootkit is. It is very difficult to find out where a rootkit is actually embedded. So that is what I can give an examples of concealment. As we told you, the first thing what we discuss under malware are viruses. So we very well know what is a virus. So you must have come across this term in some kind of sense. To have a technical understanding of what an virus is with respect to cryptography or with respect to network security is that Virus is a malicious executable code that is attached to other executable files, even legitimate programs. What it can do is it can actually replicate itself by modifying other files or programs to insert code that is capable of further replication. So if there is an infected file, maybe an exe file on your system, which you might have received it through an email or through an USB transfer or somewhere else. And once you click on that, if you try to execute that, what it does is it will automatically tries to find out where all the other executable files are and tries to infect each and every one of those files. So most viruses require end user activation and can activate at a specific time or date. So usually, unless until you click on that infected file, only then it can start executing and you can start its infection. Okay. Now, viruses can be harmless because there are some viruses on the internet which are just for jovial purposes, and where you can just, once you click on it, your picture or somebody else a caricature might be displayed on your page or on your web page. But also at the same time, they can be lethal and very destructive, such as they can even completely erase entire data or even modify the access logs or whatever it can be. So viruses can also be programmed to mutate to avoid detection. Don't take viruses easily, because a virus can be a small one or can have devastating consequences on your data. Computer viruses share some properties with their biological counterparts. You know that we call usually flu virus, all these kind of things, isn't it? So these viruses also do share some properties. Why we say that they share some properties is simply because just like their counterparts, just like their biological counterparts, the computer viruses also first attack the system, penetrates the system, then replicate within the system, and then finally release to propagate and to infect other systems. This is the same cycle through which a normal biological virus also goes through. That is the reason we say computer viruses share some of the properties with their biological counterparts. During its lifetime, a typical virus goes through the following 4 phases. Usually, the life cycle of a virus does contain 4 phases. The first phase being the dormant phase, which we call it as an idle phase, where the virus does nothing and it simply exists in the system. It is simply trying to make sure that it is not detected. The second phase is being, we call it as propagation phase. Here, the virus is replicating itself. That means it is trying to find out the other files, any other executable files, and it tries to infect them also. That is what it does in the propagation phase. The third one is called as the triggering phase. The triggering phase is something where a kind of action done which will activate the virus to start doing its performed or to start doing its intended action. So whichever or whatever function that the virus is designed to do, so it starts performing that in the triggering phase. There will be some kind of event, maybe a user executing a file or downloading something or clicking on a link, that kind of thing. So whichever event activates the virus, so it starts performing the function. And the final phase is called as the execution phase. In the execution phase, the virus completes the function it has executed already, and whichever function it is designed to do, it has completed that, and the performance and its performing is done. That is what we call as execution phase. These are the general phases in a virus life cycle. If you think that there is only one kind of virus, then you are gravely mistaken, because there are many types of viruses in existence. And once again, as the technology evolves every day, new types of viruses also are coming into play. We have different types of viruses that are currently in existence. First one being the parasitic virus, memory resident virus, boot sector virus, stealth virus, polymorphic virus, and metamorphic virus. To just give a brief explanation about these, parasitic virus is the traditional one or the old one, which where a virus simply sits on the system and identifies other executable files. It attaches itself to files so that to replicate itself. That is what we call as a parasitic virus. The second one is memory resident virus. Here, the virus lodges in the main memory itself or some part of the main memory, and it starts infecting each and every program that executes from that particular memory. that starts execute. So that is what we call as a memory resident virus. The third one is the boot sector virus. The name itself should have given you an idea, saying that the boot sector virus means a virus which infects a particular MBR or a master boot record or even a boot sector. And once the system starts booting from that particular volume or from that particular disk, the virus also gets activated and starts infecting the files that are part of your system. Next one is stealth virus, which is specifically designed to avoid detection. And the next one is polymorphic virus and metamorphic virus. So the polymorphic virus, what it does is it actually mutates with every infection and making the detection by the antivirus through the signature almost impossible. So it changes or it mutates with every infection it makes. Similarly, metamorphic virus also do change itself, but the main difference between polymorphic and metamorphic is that the metamorphic virus completely rewrites itself. The polymorphic one changes itself, but the metamorphic one completely rewrites itself, making the detection of this kind of virus even more difficult. So these are the different types of viruses. Of course, there are many other ones which you can find on the internet, maybe armored virus, macro virus, fat file allocation table virus, even directory virus. There are many other things on the internet, but these are some of the common ones of viruses that we talked about. Okay, so this is regarding the first malware or the first category of malware, which we call as virus. Let us go to the second one, which is also called as backdoor, and sometimes we call it as a trapdoor also. Now, if you're wondering, the name itself is a giveaway here. You should be able to understand what a backdoor is, isn't it? Some kind of an entry or a backstage entry kind of thing. Here also, it is nothing but it is a secret entry point into a program that allows someone who knows that there is a backdoor to gain access without going through the usual security access procedures. I'll give you a simple example. If you go to a concert, large number of people will be there and everybody has to go through a queue screening process and everything. But if you know someone or if you know where the backstage entry is, you can go there. You can straight away go in without going through all these checks, without having the need to wait, all these things. Similarly, the same concept we can apply here, which we call it as a backdoor. So backdoors are actually set up by the developers intentionally to gain special privileges to assist in case of a failure. If you are executing a program and if there is some kind of failure which you are trying to recover from and it has become very tough. So in those cases, these backdoors help the programmers or developers so that they can gain some special privileges to go inside or to enter into the program and reboot it or change it or modify it and even try to troubleshoot it to resolve the issue. So this is what a backdoor is all about. And traditionally, backdoors are kept discreet and their existence is only known for a select group of people for gaining easy access to a system or application. So we don't tell each and everyone where the backdoors are. They are only meant for very few people who try to access or whom we can give access to the system in case of an emergency or in case of any kind of issues. The backdoor. So if you when you say backdoor, you always imagine a door kind of thing, isn't it? Back door of a stage or whatever it might be. Here, in our programming point of view, the backdoor is a code that recognizes some special sequence of input or is triggered by being run from a certain user ID or by an unlikely sequence of events. So only the person who knows what kind of input to give or which user ID to work with and even what sequence of events to execute so that to activate this backdoor. Now, until now, I have been saying that the backdoors are intentionally created by developers or even programmers so that they can enter into the system without going through all the necessary checks and then try to resolve any issues. The problem becomes, or backdoors become a problem when these unscrupulous programmers use them to gain unauthorized access. So these guys are maybe some kind of evil guys, bad people who does not want to do it the ethical way. And these guys, when they try to gain access where they shouldn't have, then backdoors will become a problem. So it is difficult to implement operating system controls for backdoors. Security measures must focus on the program development and software update activities. If you go on the internet and search for backdoor case studies, one I came across is the Foggy Web, which is a backdoor exploit targeted at Solar Wind's Orion network management software. So there it was a very big, well-documented case. If you want, you can go and look at it once. Foggy Web and also the SolarWinds Orion network management software. In other words, these backdoors are also commonly found on DVDs and in software bundles like games and those kind of things, where you can enter a secret room or so, or if you press some special buttons, you might get given special coins, gifts, etc., etc. So these are the things. Of course, they are set up for fun, but once if an unauthorized person gains access to the system, then we cannot imagine what will happen to the system, or how is he going to make use of it, isn't it? So backdoors also should be taken care of. The next kind of malware uh, category is a logic bomb. This is one of the oldest programs. It actually came first even before viruses and worms as well. So the logic bomb is one of the oldest program threats, and it is nothing but a code embedded in some legitimate program that is set to explode when certain conditions are met. Don't think explosion means a bomb, blast or something like that. No, what it does is, a logic bomb is a piece of code which is intentionally inserted into a software system that will set off a malicious function when specified conditions are met. If you want to understand what a logic bomb is, let me tell you one thing. See, if I'm a disgruntled employee, my employer has kicked me out. So what I do is I place a simple piece of code inside the system saying that maybe if they didn't pass my paycheck, or if my payroll system does not include my name, then automatically all the database should be deleted, or all the databases should be dumped onto some online platform. Those kind of things are called as logic bombs. Some kind of malicious action will be taken place if those specific conditions are met. That is what we call as a logic bombs. So examples of conditions that can be used as triggers for a logic bomb are the presence or even absence of certain files, a particular day of the week or date, or a particular user running the application. Just as an example I told you, there are many logic bombs that you can see on the internet as case studies. But one of the most famous one is the one which was actually triggered by a programmer called as Tim Lloyd on his former employer called as the Omega Engineering Corporation. Because of this logic bomb, this particular company has lost almost close to $10 million and even has to lay off 80 workers. So Lloyd was caught and he was sentenced to 41 months in prison, and he was also ordered to pay $2 million in restitution to the company. So you can check on the internet to have a better understanding what went wrong, how he did it, what he did. All those kind of things are there on the internet. So this was one well-documented issue, or one well-documented case of a logic bomb. The next one, of course, you must have heard this particular term also called as Trojan Horse. When I was studying, I was a big fan of the novel the Trojan War, where the horse was the last one where they would enter this particular city. So a Trojan horse is a useful or apparently useful program or even command procedure containing hidden code that, when invoked, performs some unwanted or harmful action. In simpler terms, it looks as if it is a legitimate program and you have to execute it. Simply like there is a pop-up which tells you that, okay, please update your browser so that you might get some additional security. So what we feel is okay, fine, because it is saying security, why shouldn't I update it? And we click on the update, start downloading it, maybe download it from a third-party website. But what is happening is, in the background, the code that you're downloading not only contains the update, but also contains some kind of malicious code which might take control of your system, or which might capture some kind of sensitive data from the system and then send it to someone else. That is what a Trojan horse is about. The appearance is one, but what it actually does is completely different. So that is the reason I brought this small diagram here. See, if you can see a simple teddy bear, your program looks like a teddy bear, very cute. But once you start executing it, what it does is completely different in the background, isn't it? So Trojan horse programs can be used to accomplish functions indirectly that an unauthorized user could not accomplish directly. So if I don't have access, I don't have the privileges, what I would do is I would send a Trojan horse program so that I can either grab the credentials of a legitimate person, or even I can manipulate the system and make the system believe that I'm an authorized user. Unlike a virus or worm, Trojan malware cannot replicate itself or self-execute. It requires specific and deliberate action from the user. So as we just told you, and Trojans are designed to damage files, redirect internet traffic, monitor the user's activity, steal sensitive data, or even set up backdoor access points to the system. In a way, I got this from the internet. I like the particular word. A Trojan horse can be like a Swiss Army knife of hacking. So you know what a Swiss Army knife is. It'll have different tools in it, maybe 10 to 15 different tools in a single knife, which you can carry, which you can use it for different purposes. Similarly, a Trojan horse can also work like this Swiss Army knife for hacking, because it contains different delivery mechanisms or different tools. Of course, there are many different Trojans available on the internet. For example, it can be an exploit Trojan, it can be a downloader Trojan, it can be a ransom Trojan, backdoor Trojan, DDoS, distributed denial of service Trojan, SMS Trojan, banking Trojan, fake AV, that is fake antivirus Trojan. The list goes on and on and on. There are many different Trojan horses that are there. If you can see, so if you ask me, sir, why there are so many? Because they just look like about anything. You might be looking at a Word document, but inside my Word document, it might contain a Trojan. So Trojans can look like just about anything from free software and music to browser advertisements to seemingly legitimate apps. Even if you download a PDF reader, it might contain a Trojan horse, which might grab the control of the system and send this particular sensitive data to someone else. One of it is called as a remote RAT, R-A-T. RAT actually stands for remote access Trojan or remote access tool. So these RATs are installed when you download pirated software or software from third parties, which are not trustworthy. So these are the things, and any number of unwise user behaviors can lead to a Trojan infection. As I told you, if you get an email attachment saying that, hey, you won a 1 lakh rupees lottery, go get it. So I don't want you guys to go click those links which you receive from some person which you don't know. Just don't download software from websites that you don't trust. All these kind of things. So anything or any kind of unwise behavior can lead to a Trojan infection of your system. It is in your hands. Okay. And finally, we come to the last category of malware, which is like a zombie. Because every day we are doing this captcha and recaptcha and everything, I decided to discuss this also. So a zombie is a computer or a device. One more thing regarding the Trojan horse, I would like you guys to just go on the internet and check for I love you Trojan. You can see that is one of the most destructive cyber attack during those days in 2000s. It has led to almost $8.5 billion wastage, the losses. So just go on the internet and check out for the I love you Trojan. You will find it much more interesting to study about it. A zombie. A zombie is a computer or device infected with malware that is controlled remotely by a hacker. And zombies are used in denial of service attacks, typically against targeted websites. Let me just give you an idea of what a zombie is all about. What it is, say you just heard about a Trojan horse. You downloaded something onto your system, maybe a new movie or some kind of thing, or a new software tool which allows you to edit images, isn't it? So that might consist of a Trojan, and once you click on that particular program or executable file, automatically the Trojan is installed on your system. This Trojan will automatically give the access to a handler who can control your system now onwards. You don't even know that you are actually being a victim here, or your system has been hacked, or your system is under the control of an third party or an attacker. So now your system is called as a zombie. Now the reference, the Walking Dead, isn't it? So they don't know anything. They simply keep walking. They don't have their brains to think. That is why we call a system that has been infected and is currently under the control of a hacker or somebody else or an attacker. We call it as a zombie. So the zombies may be used to launch online attacks or send spam or phishing emails to infect other devices. A large group of these zombies is known as a botnet. In some cases, we call the zombies also as bots, BOTS, bots. And a huge collection of these things is called as a botnet. For a botnet, there will always be a controller, CNC, command and control center, through which the attacker can regulate and also monitor all these systems. So the zombie is planted on hundreds of computers belonging to unsuspecting third parties and then used to overwhelm the target website by launching an overwhelming onslaught of internet traffic. And if I want, let us say that if I want a website to go down, I don't want that business to happen. So what would I do is I usually infect any number of devices, hundreds and hundreds of devices, and wait for the right time. So when the time is right, I can give a command control center of all these systems, maybe thousands of systems, to simultaneously send a request to that particular server. So all the systems will now open the browser and tries to access the same server. What will happen? A server might be designed to handle traffic of up to 100 requests. But if I send 1000 requests, what will happen is it will automatically crash, and which makes a genuine user unable to access the server. So this is what we call as a DOS, denial of service attack, which is an attack on availability service. In some cases, when the bots are remotely placed and they don't belong to a same place, we also call it as a distributed denial of service attack. So these are some of the malware categories that we come across. But as I told you, I might not be able to teach each and every one of the examples that I told you, isn't it? There are keyloggers, there are other things, rootkits also. Keyloggers are something which can capture the keystrokes and send them to a third party or to an attacker who actually installed the keyloggers.